Hi all, let's go ahead and start on our next unit of solving systems of equations with elimination. So far we've talked about graphing and we've talked about substitution. In elimination, you have to add or subtract the equations to get an equation in one variable. Okay, so when we did graphing or when we did substitution, if we found that there was only an x and y ordered pair, that was one solution, or they met at only one point on the graph. Another type of solution is if we had all the x's and y's eliminate and we had 4 equals 4 or 7 equals 7 or -8 equals -8. Those are all true statements which would give us infinite solutions. Two parallel lines, but they're stacked right on top of each other that meet at infinite points. Another example was no solution, when we had two parallel lines that never crossed, they never touched. Right, so like for example, 8 does not equal 7, so that would be no solution. 15 does not equal -3, no solution. Okay. Here I've listed out two equations, 3x plus 2y equals 14, and -3x plus 5y equals 14. Looking at just the x terms, I've highlighted a couple of pieces. First, I've highlighted the operators, the positive and negative sign. Okay. Then I've highlighted the coefficients. That is the number in front of the variable. Right? I could have done the same thing on positive 2y and positive 5y, but I'm just focusing on the x's right now because that's what I'm going to be looking at in my first example. So our keywords for today are operators and coefficients. When we are looking at elimination, they must have at least one inverse variable term. So one must be a +3, one must be a -3, and it has to have that same variable of x. Okay, so the coefficients must be the same value, and the operators must be inverse operations. All right. Through this video, go ahead and pause it at any time that you need to write down the examples in your notebook so you have them to refer back to, as well as at the end of the video, there's going to be 4 homework problems assigned on Canvas. So go back there to find those 4, complete those, write down any questions that you have about them when you get stuck somewhere, and then submit that. Okay, I've got those same two equations, 3x plus 2y equals 14, and -3x plus 5y equals 14. I've written them down here twice. Okay, exact same problems. And I've stacked them so I can add them vertically. So one above the other, one beneath the other. Okay, so I'm going to first use this first one, and I'm going to solve for y, which means I'm going to eliminate x. Okay. Now, the two steps that I said we need to have is the coefficients of the variable need to be the exact same, and the operators need to be inverse of each other. So looking at the x's in this case, both coefficients are 3, and the operators, one is positive, one is negative. Now, with the y's, I couldn't look at that because, well, they're not the same coefficient. 2 and 5 are not the same coefficient, so I'm not going to look at those ones right now. Okay. Also, one thing that's really helpful here is when you're setting up this equation, this is really important. Make sure that the x terms are stacked, the y terms are stacked, your equals are stacked, and your constant terms are stacked, okay? Or they're both written in standard form. So when you add them together, it's easy to combine like terms, and we're not moving anything from the left side to the right side. Okay. That would be going back to substitution. So with this one here, okay, since they are the same coefficient and opposite operators or inverse operators, we're going to go ahead and add them together and combine like terms. So 3x minus 3x, those there would cancel out. In other words, they are eliminated. 2y plus 5y gives me 7y. 14 plus 14 gives me 28. Okay. Then I'm going to go ahead and divide both sides by 7 so that I can get y by itself. So we get y equals 4. Okay. So that's elimination when we're eliminating x. Now, same exact equations. What I'm going to go ahead and do on this one is eliminate y. Now, I did say that y did not have the same coefficient and they did not have opposite operators. So this one's going to take a couple more pieces. I'm going to go ahead and go through this even so. On this one here, I'm going to have to try to figure out what 2y and 5y, what value they can both be multiplied to equal. Well, both of them can go into 10. So I want one to be a 10y, and I want the other one to be a negative 10y. So this first equation, if I want 2y to be a positive 10y, I have to multiply it by 5. In this second equation, if I want this 5y to be a negative 10y, then I have to multiply it by negative 2. Okay. Now, can't just multiply one part of the equation because it's an equation. We have to multiply everything. So we are going to distribute this negative 5 to the 3x. I'm sorry, positive 5. 5 to 2y and 5 to 14. 5 times 3x gives me 15x. 5 times 2y gives me positive 10y. And 5 times 14 gives me 70. Same thing for the second equation, except this time I am distributing a negative 2 to every term. Negative 2 times negative 3x gives me a positive 6x. Negative 2 times 5y gives me negative 10y. And negative 2 times 14 gives me negative 28. And I've been able right here to find the same coefficient with the opposite operators so that I can go ahead and eliminate the y's. Okay. So those two there are eliminated. That's the goal of elimination. 15x and 6x combined to 21x equals 70 minus 28 gives me 42. Divide both sides by 21. And we've got x equals 2. So our solution on this one is 2, 4. And that is one solution. Okay. Now, most times you're going to find that there's something easier that we can do since we've already practiced substitution. Rather than doing elimination 2 times, okay, we are just going to practice doing elimination with the first set of equations and then using substitution for the second part. We already know substitution. We've practiced it many times, not just in the last week, but we've practiced it a lot. So we're going to go ahead and work with that one. So now we are going to use elimination with substitution. We've already been given inverse coefficients and the operators. Okay. So we have positive 7x and negative 7x. 7x minus 7x, well, those get eliminated. 2y and 5y, those combine to 7y equals 7. Divide both of them by 7. And we get y equals 1. Now what I'm going to do is I'm going to take that and I'm going to substitute it in to whichever of the original equations seemed easier. For me in this case, I went ahead and went with the first equation. Okay. So I've removed the y and replaced it with parentheses where I can substitute in 1. So I've got 7x plus 2 equals negative 5. Subtract 2 from both sides. And we've got 7x equals negative 7. Divide both sides by 7. and we get x equals -1. Right? There was one solution on that one. All right, so on our next example, again, we are using elimination with substitution. This time they gave us the same coefficients and they gave us the same operators. What we need is inverse operators in order to make this work. Okay, so looking at the x's and looking at the y's, if they've already met one of the criteria, when they said, hey, look, they've already given us both 6's here, I'm not going to try to do the 9x and the 2x because that would take more work. I want to find the ones that already have the same coefficient. Yes, I still need to change one of them, but I only need to change the operator. So instead of being a positive, I just need to make it a negative. So all I've got to do is multiply that entire equation by -1. So the first equation will stay the same. 9x plus 6y equals 27. -2x minus 6y equals -6. Okay, that's from distributing that -1 to every term. Remember, when we multiply or divide, it's to every term in the equation. All right. Okay, let's go ahead. What we're trying to do is eliminate the y's, and we've done that by giving them inverse operations. 9x minus 2x gives me 7x. 27 minus 6 gives me 21. Divide both by 7, and we get x equals 3. Okay. Now we are going to substitute that into one of the original equations, whichever one looked easier to you. Well, usually the one with smaller values is the one that looks easiest, so I've gone ahead and gone with the second equation. I've taken out the x variable and substituted in parentheses so that I can fill that in with that value of 3. 2 times 3 is 6, plus 6y equals 6. Subtract 6 from both sides of the equal sign. Okay, make sure that you realize that's both sides of the equal sign. These two here are gone. So I've got 6y equals 0. Divide both sides by 6. 0 divided by anything is still 0. So our solution on this one is 3, 0. Okay. All right, one more example. This time we are going to be using elimination with substitution. We are going to be given two different coefficients and the same operators. So in this case, we need to manipulate both equations so that we can get them the same coefficient and opposite operators. Okay. So I noticed that the x's, they don't have the same coefficient. Looking at the y's, they don't have the same coefficient. They're all positive, so none of them have opposite operators. Now remember, we're only looking at the variable terms. We are not looking at the constant terms. Okay. So what I'm going to do, since I don't have a nice place to start, I'm just going to go ahead and start with the x's. Okay. And I'm going to try to get these two to eliminate. That's my goal. Well, in order to make them eliminate, okay, I've got to multiply the first equation and the second equation by something that will make them the same coefficient value. So what number would 5 and 3 both multiply to? Okay. What I could do here is I could multiply the top equation by 3 and the bottom equation by 5. Okay. What that will allow me to do is that will give me the same coefficient. Okay, let me erase that. It looks kind of messy there. That's going to give me the same coefficient. However, one of them is going to need to be negative so that they can have opposite operators. Now, if you were to go back and look at the first equation that we did, where we solved for y, we've already done this. Okay, so this first one, I'm going to go ahead and multiply by 3. This second equation, I'm going to multiply by 5, but it's going to be a negative 5. Distribution, 3 times 5x gives me 15x. 3 times 4y gives me positive 12y. And 3 times negative 14 gives me negative 42. Okay. Negative 5 times 3x gives me negative 15x. Negative 5 times positive 6y gives me negative 30y. And negative 5 times 6 gives me negative 30. Okay. Our x's now have the same coefficient and opposite operators. Okay. The x's are eliminated. 12y minus 30y gives me negative 18y. Negative 42 and negative 30 give me negative 72. Divide them both by negative 18. And we get y equals positive 4. So negative divided by a negative makes it a positive. Again, pick one of your original equations to do substitution. I feel like the second one looks easier to me, so that's the one I'm going to go with. Okay, instead of 6, I'm going to substitute in that 4 that we had for y. Or not instead of 6. Instead of y, I'm substituting in 4. So we've got 3x plus 24 equals 6. Subtract 24 from both sides. Remember, that is, again, both sides of the equation. So we've got 3x equals negative 18. Divide both sides by 3. And we have x equals negative 6. Our ordered pair is negative 6, 4. Okay. All right, I have gone ahead and listed the same steps that I've talked about here in this video. Go to Canvas, complete the 4 assignments that you've been assigned, the 4 equations you've been assigned, and please, please, please send me any reminds if you have any questions. All right, hope you all have a great afternoon.